In a recent poll of 740 randomly selected adults, 586 said that it is morally wrong to not report all income on tax returns. Use a 0.05 significance level to test the claim that 75% of adults say that it is morally wrong to not report all income on tax returns. Identify the null hypothesis, alternative hypothesis, test statistic, p-value, conclusion about the null hypothesis. We're working with a proportion problem. We have a one sample proportion problem. It's a hypothesis test, and the first thing that we'll need to do is identify the hypotheses. One thing that I like to do is compare this to a curve. Look at the curve and see what we can figure about the problem. The claim is that 75% of adults say that it is morally wrong. So the hypothesis is that the population proportion is 0.75. The thing that we have to keep in mind is that we're working with a sample. And in order for a sample to lead us to draw a conclusion, we would have to show that we have significant results. In other words, if my sample proportion landed somewhere around in this area here, that's pretty close to my hypothesized population proportion and wouldn't necessarily lead me to conclude that the population proportion is not 0.75. But if I landed way down in this tail down here or way up here in this tail up here with my sample proportion, then I would start to say, well, I don't know that I believe that the population proportion is 0.75 because it is so unlikely that my sample proportion would land up in this tail or way down in this tail if the population proportion was 0.75. So we have a two-tailed test, and our null hypothesis would be p equal to 0.75, and our alternative hypothesis would be p not equal to 0.75. Identifying the parts that we've got here, we can see that n, the number in the poll, is 740. And x, the number who responded that it is morally wrong, is 586. So our sample proportion would be 586 out of 740. If we were to express that as a decimal, we would get 0.79 after we round to two decimal places. Okay, well that is not 0.75. It's larger than 0.75, but is it way up here in this tail? Is it that far? Well, we need to determine that by calculating the test statistic and the p-value. In order to do that, we can use Statcrunch. We'll click Stat, Proportions, One Sample with Summary. Our number of successes was 586. Our number of observations was 740. Hit Next. We're conducting a hypothesis test, so we want this radio button to be selected. And our null hypothesis specified the hypothesized proportion as 0.75. The alternative hypothesis we should have not equal to, so that the calculator calculates this as a two-tailed test. Then we'll hit Next, Calculate, and we get a z-statistic of 2.63 and a p-value of 0.0085. So our z-statistic, or our z-test value, is 2.63, and our p-value is 0.0085. Now, if we were to draw our conclusion based on the p-value, we would do that by noting that the p-value is less than alpha. The p-value is 0.0085, and our significance level was 0.05. Anytime the p-value is less than alpha, we should reject the null hypothesis. Now, why would we do that? Well, if this is a two-tailed test, then alpha equal to 0.05 is split out into the two tails here. So we'd have 0.025 in this tail and 0.025 of the distribution in this tail. Now, we have decided that if our test statistic lands way down here below this critical value here, or way up here above this critical value, we would question whether or not the actual population proportion is 0.75. Now, the p-value is the area in the tail above the test statistic. So if our z-test value is up here above this critical spot, or down here below this critical spot, then we would reject the null hypothesis. In other words, we wouldn't believe that the population proportion is 0.75. Well, that's what happened, because we found that our p-value is 0.0085. Well, the only way that the p-value, which is the area in the tail outside of the test value, can be less than alpha is if we have this situation where the test value is larger than the critical value. So we'll reject the null hypothesis, and we could write our conclusion in this way. Sufficient evidence was gathered at the 0.05 level of significance to conclude that the actual population proportion is not 0.75.